Hello, my name is Okechukwu Igwe, and today I'm here to present my Tetuan City Power Conception project. This is going to be a how-to demonstration video for my Tetuan City Power Conception project. In this video, I'm going to walk through how the project is completed step by step, the model strategies I use, the challenges I ran into, and how I managed to divide and manage the work on my own. By the end, you'll see how I built predictive models for power consumption across three different zones in Tetuan, Morocco, using weather variables like temperature, humidity, and wind speed. The main goal of the project was to analyze real-world electrical consumption data from Tetuan in 2017 and predict the power consumption in three zones using machine learning models. We were given a data set with 7 columns: daytime, temperature, humidity, wind speed, and the power consumption for zone 1, zone 2, and zone 3. Our task My task was to complete a short literature review, perform exploratory data analysis, build predictive models, and finally create a user interface function that returns estimated power consumption. To begin, I completed a literature scan to understand the relationship between weather variables and electricity demand. I reviewed three main sources: a Medium article on weather based energy prediction, an academic study by Hernandez et al., and an NREL report on building energy consumption. Together, these sources help me justify why temperature, humidity, and wind speed should also be used as inputs. They also show that predictive modeling is commonly used in smart grid research and city level planning. Next, I loaded the Tetuan dataset into a Jupyter notebook. One of the first challenges I encountered was mismatched column names. This dataset used inconsistent capitalization and spacing, such as Zone 1 power consumption. Let me show an example. As you can see right here, it used Zone 1 power consumption instead of just this right here, Zone 1. And instead of wind speed right here with a space, it used wind speed with an underscore with the two first letters for each word undercased. To fix this, I could have just printed the column names and manually rewrote the rename dictionary to match the dataset exactly. But instead, I chose to just single-handedly pick out and make sure each name was the same as it was on the Tetuan dataset on the sheets. This step is crucial because any incorrect spelling or space causes key errors. After fixing my problem, I converted the datetime column into a datetime object instead as an index. Then I checked the missing values and confirmed that the dataset was clean. For my exploratory data analysis, I plotted time series graphs showing how power consumption changed throughout the years in all three zones. I also created histogram and pair plots to visualize relationships between weather variables and power outputs. One of the clearest findings was that temperature had the strongest correlation with power consumption across all three zones, which aligns with published research. Humidity also showed moderate correlation, while wind speed appeared to have a weaker or non-linear relationship. The pair plot helped me visually confirm this before modeling. As you can see, here's my exploratory data analysis, the code needed to create, and here all three zones, histograms as well, the pair plots for each zone, as long as with the correlation matrix. Next was the model building phase. Separate the data set into features: temperature, humidity, wind speed, and target zones: zone 1, zone 2, and zone 3 power consumption. I use trained test splits to evaluate my models fairly. For each zone, I built three models. One of them, the multiple linear regression model, the ridge regression model, and the random forest regressor model. I used standardized scaling for the linear models and left the random forest model unscaled. When then evaluating each model using R squared and RMSE to measure how well they fit the data. In almost all cases, the random forest model performed the best because it captures non-linear relationships. However, in some zones, ridge or linear regression perform similarly well. After selecting the best model for each zone, I built a user input interface function. The function takes three inputs: temperature, humidity, winds, and wind speed, and returns predicted power consumptions in all three. The function also provides an uncertainty estimate by adding and subtracting the model's RMSE. This gives users a realistic range of expected power consumption. Finally, we tested the function using three assigned weather scenarios to verify that the interface performed correctly. Throughout the although the project was successful, there were several problems I ran into that I was not able to solve completely. One was model interpretability. The random forest model gave the best performance, but it's not easily interpretable. We were not able to perform full feature importance analysis or SHAP values due to time limitations. Another one was scaling time series effects. We did not incorporate seasonality or time of day effects. Power demand often depends heavily on time, but this model only used weather variables. Adding time features could improve accuracy significantly. And one of the last ones was user interface limitations. My interface is text based inside Jupyter. A full interactive GUI or web app would offer a better user experience. Keep in mind, these issues did not block the main goal, but they highlight areas for improvement in the future work. I ended up doing this project by myself, so I was able to handle the data cleaning, help rename the columns, and solve key errors. Perform the exploratory data analysis, including pair plots and the correlation matrices. Built and validated all three model types for each zone. Tested the user interface function and generated the final predictions, and collaborated on the written explanation and video preparation, or should I say, revise my own thing. But that's it. That's everything. I appreciate you for watching my demonstration over the Tetuan power consumption model, over my Tetuan power consumption modeling project. I covered the full workflow from literature review to model building and predictions, and discussed the challenges and teamwork behind, or not, discuss the challenges and hard work put in behind my project. I hope this video provides a clear understanding of how to analyze and model real world power consumption data using Python. Thank you very much.